come back and we'll hit the other problem. So content review number 2. What term refers to the situation in which electrons are shared by more than 2 atoms? There's technically 2 answers for this. Alright, so what will be the answer to it? Alright, Quentin.
Delocalization.
Good job.
It refers to the situation in which electrons are shared by more than 2 atoms.
Good up for resonance. Either term works for it. Alright, number 3. What is meant whenever a molecule is described as being polar? Alright, Ethan the gerbil.
It does not match its pair.
What?
I think I'm around with that.
What
It
did
does not match its pair, that's what I put.
Okay, I couldn't understand that.
It does not match its pair.
Does not match its pair?
That's what I put.
Okay.
I did not know what to do on that.
Like a technical.
Where was it? 130, 139?
Yeah, 139 number 2. Okay, I think I know what you're getting at. It's just not clear what you're meaning for it. Alright, so Chris, what have you got?
Oh, and it's not non-polar.
A molecule that is symmetrically distributed is a polar molecule.
Symmetrically or asymmetrically?
Symmetrically.
No,
Is it
asymmetrically.
A?
Okay, so what do you got?
When electrons and covalent bond are shared unequally.
Yeah, so asymmetrical
What is
shape
that?
or they're unequal sharing.
I
It's
thought
the
it was
idea of
unequal.
there is a positive and a negative in on the molecule. Instead of it
Yes.
being just like a polar bond between just 2 atoms, it's over the whole molecule now. Alright, number 2. So you were supposed to do for this one because some of them are harder. It was A, C, E, and G. We'll come back and hit the other ones later on. Those are just to help you just have practice for it. Alright, so SiH4. What shape would that one have? We'll talk these through in class a little bit later on. If you said there and went, I have no idea what he's talking about. You're gonna talk through them. Alright, so what have you got, Quentin?
Tetrahedral.
Final answer?
Yes.
That is correct. Alright, letter
That's
C.
what it was asking?
Yeah, it's asking just for the
I
shape.
drew it.
I drew it too.
Okay, well if you can look at the shape and go, oh,
I think
okay.
you said draw it.
Yeah, it does say draw it as well. Alright, so how'd you draw it?
Is that a homework thing?
It's already-
White tetrahedral.
Since you did part of it,
I didn't
we'll let
either,
it
because
go.
I didn't know what it meant by that.
Since you did part of it, we'll let it go to but make sure to read the whole question for it. Because you did part of it, just not the whole thing for it. Alright.
Sanhedrin.
No. Alright, so what's the shape look like?
SI.
Get out of the center.
4 lines coming out. And each one of those.
Get up. What type of bond is this as a side note? Like just a little single one.
Chemical bond. Double bond. Single bond.
Single bond, so there's 2 electrons in each spot, so silicon is happy, and each of the hydrogens is happy, and yes, this is tetrahedral. Now keep in mind, in real life, because it's a 3D substance, it would look like this. It's just really hard to draw this on a 2D object or on your paper, so if you draw it like that, that's fine, I know what you meant, but this is technically what the shape looks like. This is a tetrahedral, it's not flat like that. Okay.
Am I the only one that heard that beat when you were drawing the H? It was like dun 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 dun.
I think it's just the chalk.
It was crazy sounding.
Alright, anyone have any questions about this letter A first one then?
No.
I have to say,
Alright, you wanna do C? Alright,
C.
so we'll let you draw it out first. Alright, so what have you got?
the linear one, right?
Not quite, that's a good guess though. It's not linear.
Okay, so it's.
Okay, so S is in the center. Yeah, Jacob can see this. Alright, S in the center. S starts off with how
Yeah,
many electrons?
6.
Which one?
6.
1, 2, 3, 4, 5, 6. Alright, and then how many more does it need to be happy? 2 more. Good job. Alright, so because of that, alright, so hydrogen is going to bond up to it. So each hydrogen comes up. Now each hydrogen brings how many?
1.
1. So this hydrogen will bring 1. I'm going to shift this one over.
So
This
it's
hydrogen will
happy
be
now.
1. What?
So it's happy now.
It is happy now for it. So these are locked in and these are locked in. Moved it.
So what is that called?
Wait, we're not done. So
Trigonal
these are,
linear.
wait. So you have a bond here and a bond here, but you have 2 regions of unpaired electrons. Do you remember what this shape is? Where you have 2 bonds?
Angular geometry. Angular.
Yep, this one is angular. So that's why this one, we'll go over this in class more. This is why this one is angular. Because you have to know, okay, where's the unpaired electrons at? Because they will influence the shape still because they don't like each other, so they'll spread out. Alright, don't have any questions about that though, but we're gonna go over it more in class. Alright, letter E was the next one. I'm gonna erase these. Alright, Chris, your turn.
NC in the middle,
Good job.
and then CL.
Okay, so like, did you draw
Right
it?
side. Does it matter the side?
It will.
How do you know which side to draw it on?
Okay, so,
I drew it on the right side.
okay, that's fine.
Could you draw it on the left side?
Yeah.
Okay, so it doesn't matter which side you draw on that way.
For that side, yes. Okay, but, so how many does selenium start off with?
Is it 6?
It's 6. Alright, so 1, 2, 3, 4, 5, 6. How much? What? Alright, so how much will each chlorine share with them? Even though chlorine starts off with 7, how many will it share with it? Because how many does chlorine need to be happy?
One.
1. Alright, so
Quinn.
it'll share one of them. So each chlorine will bring over 1 and take one of selenium's 1. So that way each chlorine is happy. Now, is selenium happy as well? Yes, it is. So we have two paired electrons, or 2 bond electrons, and then 2 regions of unpaired electrons. So what shape is this? This is angular again. So that's the only reason why because if you wrote CL down here, you're still not wrong, but you gotta have your 2 dots on either side to represent this shape for it. So as long as you put your dots in the correct spot still, you're still fine. But you don't want to leave off your dots and write it like this. That's a really bad idea. Because this looks like linear, and that's not the shape it'll have. But if you put your dots off to the side, it looks weird, but I know what you mean. That it has 2 regions. You're just drawing it up and down like this, which is kind of funky. You don't want to draw it that way. Okay.
Did you guys know
Alright, so you've seen Harry Potter.
Question.
Is this related to
No,
this?
yes, it is.
It is
It will be a
sure?
way to help me remember that.
Okay.
In Quidditch, in Harry Potter,
Okay.
what is the ball they hit called?
I do not know that.
No, because when it opens, that's what it looks like. And when it's flying,
No,
that's exactly
I'm
what it
just
looks
hoping
like.
to remember this is called angular.
Cause I know what that ball looks like, and when I think of the ball, I'll think of that.
Okay, just remember, as long as you remember that this is angular, that's fine. Alright, so what were you asking me, Manuel? Or asking?
how many selenium needs to be happy? Or do you guys how many?
I thought I said chlorine. Chlorine starts off with 7. How many does it
Oh, I
need to
thought
be
it was
happy? And that's
chlorine.
how come we were just waiting. But yeah, selenium and chlorine both want how many total to be happy? 8. So that's only what they get to. Selenium starts off with 6, so they need 2 more, and then chlorine starts with 7, so they need 1
The
more.
only reason I drew 2 CLs is because it said CL2.
I mean, that's the reason why the molecule says, like, okay, draw the shape. So yeah, you were just following the instructions, that's fine for it. Alright,
Is that what's gonna be like on this theoretical quiz?
this, today, on the theoretical quiz, no, because
Is
you
that
haven't
gonna be on there?
practiced. What?
Is that gonna be on the theoretical quiz?
On the theoretical quiz eventually,
Today.
today, no. Because we haven't practiced this enough yet, I wanna make sure we practice. Alright, Quentin, or does anyone want
Me.
H? Okay,
Me.
well, you said me first.
Put
Okay,
a P in the middle.
that's right. Let's see, E, aren't you supposed, yeah, it was
H.
G, okay.
P.
I said H, I'm sorry, G. Alright, so P in the center, E.
And then, put the eyes
I drew that really bad.
as not an eye.
Yeah. This is whatever, my
That's not how I drew
dyslexia
mine. I drew
shows
mine
up.
like boom, 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 like boom, boom, boom. I didn't draw them at an angle.
Boom, boom, boom.
Put that back. Okay, so like, that.
Yeah, except opposite. Does that work?
That worked. Okay, whoa. Alright, you're missing one thing. Alright, is each eye happy?
Yes.
Yes, each eye is happy. Is P happy, as you have written it right this second? How many's here?
One.
Okay, so P's 1 and then I's 1, so how many total?
2.
2. How many here?
2.
How many here?
It needs one more. Draw 2 dots on both sides.
Alright, now that'll change the shape, because there are 2 different triangle shapes. We haven't talked about this one yet, but there's this shape, which we haven't talked about yet, and then there's this shape. So, what shape is it?
One on the right.
My right or your right?
Alright.
So this one, correct. You remember what the shape is called? Where it has the three of them on the bottom and the little electron cloud at the top?
Tripod.
There's a better name than tripod. The book does compare it to a tripod though, but
So there's what was the first one? There's
tetrahedral.
Is that a triahedral?
That's a
Sand-
good guess, but
sandhedral?
no. We talked about this with the Great Pyramids in Giza. You remember what they're called?
Oh, bases.
Not quite. Anyone else remember what this was called? Alright, Ethan?
Trigonal pyramidal?
Yep, trigonal pyramid, because there's 3 electrons at the bottom, so trigonal pyramidal, because it makes a pyramid shape. It's not flat like this one. So we'll talk about these two a little bit in a minute. Alright, we have a question. Wait.
Pyramids of Giza and four sides.
I know, like I said, we talked about it with pyramids of Giza. So again, this is not an accurate representation, but because it has tri on the bottom, but it makes a pyramid shape, like if you were to do a 3D triangle. I gotta
I
start
wanna
rubbing
cry.
shop.
I got razor burn like this.
So if you were to draw like a 3D pyramid like that, that's what it's talking about. With the idea of you have really bad 3D pyramid. Don't tell Miss Judy that's the idea what is bad. But that's the idea of, okay, you have like the base at the bottom. That's not the right one. Like you have the 3 of them at the bottom and it makes an upward shape. So it looks kind of like an angle for it. And again, I do that very badly, I'm sorry. Alright, you have any questions about that? Alright, we can play the dart game if we move quickly.
Looks like a trophy system for Call of Duty.
Do it very quickly. Alright, we'll start. I think I started with Chris yesterday, so we'll start with I think I started with Quentin on Monday.
Yeah, but we start with them all the time.
We'll start with Ethan. Ethan never gets to start, I feel like. Alright, Ethan.
He starts every game.
Alright, Ethan, you get back over it. What is
What?
Every basketball game.
What is alright, first of all, what is the attractive force that holds the atoms in a molecule together? So let's just do that term first off.
The attractive force that holds.
Sorry, Jamie, y'all do not let me forget so that Jamie's not staring at the ceiling. Sorry, Jamie.
Oh, shucks. The attractive force that what?
That holds the atoms in a molecule together. There are 3 different types of this.
Let's see,
This is why you don't start.
Oh. That, yesterday? Charge of, ion? Charge electron.
Okay, ionic, covalent, and metallic are examples of this.
Say it again, please.
Okay, what do you call an attractive force that holds the atoms of a molecule together?
Chemical bonds?
Chemical bonds, that's all I needed. I'm gonna shrink this down a little bit.
I thought you were gonna say chemical reaction when you first said chemical.
No, you get to use the blue
But
one.
did I?
You get it if you want.
And burn.
Hey, it might slip though. Or pop up. Hey, alright, we'll go this direction. So Quentin's turn. Alright, Quentin, what rule says that they want to get 8 valence electrons? Optical.
Then she's gonna give me like, what is some scientist's name from the first chapter? Look at these ones.
Those will come later. Whenever we're getting ready for your exam. 2. Alright, what is the most important factor to determine how an atom will bond together? I guess V, depending on how you say this.
Valence electrons?
Yeah, because they want to either lose their valence electrons or gain them.
Over.
Don't go too hard, don't get my board. That was a very nice toss, good job. Alright,
It's like
Ethan
me,
turn.
that's like me before the game yesterday.
alright, there are 3 different types of bonds. What do you call the bond that's characterized by the sharing of electrons? They're both hanging onto it.
Star one?
So, there's 3 different types of bonds. Ionic, covalent, metallic. Which one?
One more time.
Ionic, covalent, metallic. Which one is characterized by sharing? They're both hanging onto it at the same time.
Oh, covalent?
Final answer?
Yes.
Covalent is correct. They are both sharing.
The arc of covalent.
If that helps you, okay, but just make sure that you do know the term for it.
So was the arc of the covalent in the temple?
Yeah. And then it disappeared.
Do you think this Rambo's just gone? Some people think it's on Oak Island.
I think
I
it's just
in
hidden.
heaven. I think it's in heaven. Or like hidden on Earth
Yeah, I think it's hidden
by
on
like the
there.
Nice Crusaders or something.
Possibly. I just think that, I think someone has it, or they might not even realize what it is, and it's like in storage
It's
somewhere.
just like some like Pandora's box or something.
There's like, oh, I've had this box for like forever, and grandfather's had it, and I don't know what's in it.
Opens
So-
it up and gets smited.
Quite possibly, yeah. Alright, so your turn. Let's see, what type of bond is characterized by, as your book puts it, the sea of electrons, because nobody wants them, because they're all getting thrown off. Metallic is correct.
Twin.
Yeah.
Ionic.
I'm not to you, wait. Alright, what is the definition of an ionic bond then?
Between metal and non-metal.
I'll take that, good job.
You thought you stumped me.
I was getting ready,
I'm too smart.
I wasn't sure. But hey, at least you know it, that means you'll know it in a couple of minutes too.
Ooh. That means we have food.
Possibly. You
You-
should
you
always
already
know
told us.
everything.
So covalent likes to share.
Is that 16
Covalent
or
share.
7? Is that 16 or
And then-
7?
Oh,
It's
oh,
16 now.
oh, oh,
16.
Ian
It is
touched it.
16, because it moved on its own and you didn't touch it. You did not
I breathed
influence
on it.
it.
Ionic is what?
That's okay, ionic is characterized by the exchanging or transferring of electrons. One of them's throwing it away, one of them's taking it. Alright, which one is between a non-metal to a non-metal?
Oh, I think.
Yes.
Say it again.
Which one is between a non-metal to a non-metal?
Covalent.
Covalent is correct.
I was wanting
Good
to say
job.
metallic so bad.
Because
I
remember,
thought it was
they're
gonna
both
say one
sharing
guy
because they both
laughing.
want them.
I wasn't going to say that. I already rolled that out.
What are we playing? Clue?
It might slip.
Is that 25?
Throw your next
That's in the
one
middle.
because you gotta see where it ends up.
Nice.
Well, they're both on
I've never seen that.
Hell.
attracted to their own magnet.
I
Alright,
wish someone was attracted.
what is
Wait, metallic is what?
metallic? Metallic
Ask
is
a question.
whenever.
No, ask a question.
What type of bond is between metals and metals?
Metallic.
Metallic. That's because nobody wants them, so they all throw it off.
Nobody wants.
No one wants me either.
No,
On a roll today.
Chris.
Eat a
Don't
mind
write
depression.
that on the quiz. I'm sorry, Quinn.
2.
Alright, which one, okay, why does the metal and the non-metal stick together? Because remember, they're not sharing electrons, so what's making them actually stick together?
Because the metal wants to give away an electron.
Okay, so metal yeeted it off,
Yeah.
and non-metal took it, so it's not the electron holding them together, what's making them hold together? C, because you had this yesterday, or E,
Yeah.
is the same question I think you got yesterday.
And it's not chemical or anything. So. Is it the covalent networks?
For an ionic bond, you're gonna go with covalent network.
Oh, is it the I remember this. Okay.
If you can just describe it, I'll take it.
Use like the electric current.
You're close enough. Electrical charge, because it's the
That's what it was.
cation and the anion that
that's
stick
what it was.
together. You have the right
So
idea.
that's what again?
That's what makes the ionic bond stick together, is the charge.
2.
That's on the line.
That's half. Or that's 15. Okay.
Yeah, that's on the line.
It's on the line, so 2 or 1, because it's over.
My memory's not.
Let's see.
Explanation.
I think I've asked all the different types for it so far. Don't leave that alone. You did not consent for that.
Did you consent? He said he consented.
Alright, so how many electrons are being shared in a double bond?
Consent is key.
Whose turn is it? Oh, it's
How many electrons are being shared in the double bond?
Mhm.
4.
4. Alright, and a single is, and a triple is, okay, so yeah, so then let's get rid of all those really quick.
4.
That's 4. That's all.
That's all.
Let me look
That's
at it.
all.
On the line.
Even
It's
it's
all-
off, it's like barely touching it.
This man's playing by volleyball
Alright.
rules.
You got this yesterday
This man's playing by
too.
soccer rules.
What is an example of a covalent network?
Diamond.
Diamond or quartz?
Go on.
Diamonds! Oh!
What's the question again? I didn't hear it.
Covalent networks. Make sure you pay attention instead of talking about soccer. So, covalent networks. Diamond and quartz.
That was great. Let's talk about soccer.
13 and 12, not bad, 25.
Alright, what type of bond gives the characteristics of good conductors of heat and electricity? Yeah, malleable and ductile. Ductile.
What?
Electricity, yeah.
What likes electricity? Is basically what you just asked.
Alright, what type of bond? Metallic bond.
I know not to use that one anymore.
Causes them to have good conductors of heat, electricity,
Metallic.
and metallic, and they're malleable and ductile.
Metallic.
Bonds. Alright, what do you call equal sharing between, this is your turn.
Do you like my
Equal-
drawing on the back of my homework?
I don't know if I looked at it. I'm sorry. What do you call the equal sharing of electrons in a molecule?
This turn.
It's even.
Just start with.
In.
Wow.
N.
It's a Spanish word, but no.
None.
Typically known for.
I don't know it. I don't know.
Alright, first raise your hand. Equal sharing. Go. Question.
Non-polar.
Non-polar.
Chris, you know?
What?
Oh.
I didn't hear her say
It's
no.
too late
I
now.
said go, yeah.
It's too late now.
I'm sorry. Equal sharing, non-polar. Unequal sharing, polar.
Why is it when he throws, he gets big numbers every time, and when it falls off, he
When he
doesn't.
plays basketball, he doesn't.
Yeah, no, right.
Alright, what do you call, what is the symbol we use to represent the partial charge?
Reverse delta.
What?
Reverse delta. The lowercase delta.
There you go. I was like, I'm not sure if I can take reverse delta.
How do you draw lowercase delta again?
It's a little weird.
Do we have to draw it?
No. But you'd be able to recognize it if it asked you what's the name for this letter. Watch out for Ted. Alright, what do you call a molecule that has two sides? You acted like you thought Ted was gonna assault you. You were
No. No.
What happened?
We don't talk about it.
Okay. Ethan's turn.
We don't talk about it.
Alright, Ethan, what do you call a molecule that has two sides because of the polar bond? So it has a positive, partial positive and partial negative end. Okay, what means two?
God.
Alright.
Oh, God, polar.
Dipole. I'll take that. Dipole. So there's two
What is
poles.
that? What is that weird bird? Mystery, it's a fossil. I was like the dog.
Oh.
Dodo?
Huh?
Dodo?
Dogo.
Dodo.
That's
Dodo
an
bird?
extinct
No,
bird.
no, not that. It's living in like the tree Diaptolus.
Off the top of my head, I'm not sure.
Diaptolus.
I think I know
16!
what it is.
Hey, even said it.
Alright,
I played
What?
That
example.
one's like all the way down.
I know, right?
what do we call the diagrams we use to represent the molecules? I'm gonna redraw them on the board.
Blue structure.
Lewis structures.
Useless.
Me.
Lewis structures. Don't forget.
Complete waste of my time.
Trash.
I'm sorry.
I thought that was
No luck.
one.
I thought it was gonna. Ooh.
That's 25.
Yeah, that is 25.
What did I tell you?
Alright,
Wait,
what do
wait,
we call
wait.
electrons that are free to circulate in the atom or molecule? They're not locked in. What do we call this?
What was the question? What was
Not
the
long.
answer for yours?
But what's the better term for them?
Delocalized.
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 Just like the
Oh.
people that were affected by Hurricane Katrina.
But that helps to remember this. Don't throw too hard. Not too hard.
Delocalized?
Delocalized electrons.
That's like me shooting.
Alright, Chris, you're about to get fired from throwing. Make sure you're throwing lighter. I don't want you to dent up my board. Alright, what is, I'm gonna ignore it for right now.
Just
What do you
call
call,
magnetism.
what do you call a bonding situation whenever you have the electrons are free to circulate? So it's not the electrons, what do we call the situation?
Let's start with
D,
delocalization.
good job, or resonance, either one.
What are you doing, cuz? That's strong, magnetism.
Yeah, it's a good pull. It might slip.
Come on, that was
At
on
least it's
10.
a 10.
That's a barometer.
Alright, so what type of bond is between non-metal and non-metal?
What's that?
Yo,
Are we gonna get a periodic table first, you want first?
I will tell you, I mean, you have it right there, but I gotta tell it for Jamie and potentially
Covalent.
Covalent.
Last question? Cause then it's even.
Ethan started.
Yeah, so I have to.
Yeah, you get one more.
Oh man. What's
Alright,
I'll
what
take it to
bond is characterized by a sea of electrons?
That's what happened.
Cause nobody wants them.
What's the? You localize?
What type of bond?
Covalent.
Final answer? No, first person to raise your hand. Which one is characterized by a sea of electrons, cause nobody wants them? Go.
That was me, that was me.
Barely got it, you were clear next though.
Metallic.
Metallic, cause nobody wants them, they're all
Okay,
thrown
okay.
off. So it's delocalized electrons, but it's metallic bonds.
I don't think even 250s could help you right now.
Doesn't matter.
Good effort.
Oh no, but
I'm sorry,
Nice.
then I'm very sorry.
219 like alcohol.
Alright, anyone have any questions about the different types of bonds and what they do?
Can I ask Ethan if I can get a piece of paper?
You may ask either motherfucker being a paper.
Dad,
Nope.
Alright.
Can I have
Yeah.
Hi,
a piece of
Jamie.
paper, Dad?
Did not forget you, Jamie. Alright, Jamie, pause the video
Oh.
and go ask your parents for quiz 14. Don't watch the rest of the video until you're able to get it. So
Wait, is
pause
this-
the video. Wait,
okay.
I got that too. So make sure you pause the video and go get this and then come back. It's quiz 14. It should be in the packet. Alright, everyone else should have on a cover sheet.
do I need one?
You're so far away, you don't need one.
Can I use my arm?
You already have one out. Alright, put it away, Ethan, we gotta go. Alright, so matching section for that first section. Matching description with the correct term. Answers may be used more than once for it.
I'm stupid, I saw quiz 14 on here.
I was wondering what you were doing. Alright,
Just the math box.
so for that section, make sure you're matching it carefully. Pay attention to what you're doing as you're going through it in that section. Alright, Jamie, because you probably don't have the periodic table up in the room, now if you have the piece of paper still that has just the periodic table on it, you can use that instead. But I will tell you for lower down in that section, I will tell you if it's a metal or a non-metal, because that's ultimately what it's asking in that section. So, let me get over to that page. Alright, so for number 5, so that way it's fair for everyone, that's sulfur and oxygen. Hopefully you know those are two non-metals. So for that one, for number 5, it's asking you what type of bond for number 5 is between two non-metals, because that's sulfur and oxygen. Number 6, that's aluminum and nickel. Those are two metals. So for number 6, it's asking you what type of bond is between aluminum and nickel, since they're two metals. Alright. Number 7, that's calcium difluoride. So that is a metal and a non-metal. So what type of bond is between a metal and a non-metal? So that's for 5, 6, and 7. The rest of it you should be able to figure out based on the wait, stop. So which type? So because of that, you should be able to figure out for the rest of them based on the wording of it. All right, Chris, what was your question?
What does number 4 mean?
Number 4, cations are attracted to anions. It's the idea of they're charged. Hopefully you remember what a cation is, what an anion is, what bond has to do with the charges, and what holds them together. So again, Jamie, just so that way it's clear for you as well, sulfur and oxygen are both nonmetals. So what bond is that? Number 6, aluminum and nickel are both metals. So which one has that bond? And then number 7, that one is a metal and a non-metal. So which one has that type of bond?
Number 4.
Talked about it before. Well, obviously interest can be used more than once, I didn't say that, but obviously they can be. In completion, write the words that best completes the sentence. Take a stab at it, Ethan, it's 1 and 3, just try hard and guess.
Let's start with,
No, 1 and 3, guess. Cations and anions have charges, so which one is characterized by the charges holding them together? Take a stab at it. Alright, anyone need more time?
what was it?
Wait, are you done?
Yeah.
Jamie, don't watch the rest of this until you finish taking it, so hang on, let me take it from it, and then I'll tell you. Alright, I'm assuming, Jamie, you finish it and you put it off to the side now, so to answer your question, it is ionic, because remember it's the charges that hold them together. Since the one metal's throwing away the electron, the other one's taking it, it's now the positive or negative charges or cations and anions sticking together. That's the reason
What is the
why.
one that produces a malleable substance? Is that?
That's metallic.
So,
Because remember, they conduct electricity, they
Sharing
conduct
one's
heat.
covalent, right?
What, sharing? Is covalent.
And then, number 9, that was chemical, right?
so ion was B, right?
So, wait, what?
Ion was B, wasn't it?
Yeah, ion
Alright.
speed. What were you asking?
Chemical for number 9,
Okay, unequal sharing of electron produces what type of bond?
chemical.
Unequal sharing.
What's number,
Polar.
what's number 9?
We'll go over it later. Okay, we gotta keep going. So,
Polar.
you'll find out later. Alright, so, flip over in your textbook to page number 137, 138, talking about these Vesper models, or how to use these shapes for it. You're gonna need to know how to do this, because this is one of the labs we're gonna actually do in class. So for this one, it actually gets fun for you to actually be able to build them out. So make sure as we're going through it and getting practice with them that you understand and ask questions, what am I doing? Because during the actual lab, there's not a whole lot of time to stop and ask me, what am I doing? What am I doing?
138.
What?
138.
Yeah, on 130, 137 is where it starts, and then 138 is where it's going for.
Are we gonna watch a cool video today?
Alright, yes, Ethan.
Are we gonna make a hydrogen bomb in this class?
Did you do what?
Are we gonna make a hydrogen bomb in this class?
Do you think we're gonna make a hydrogen bomb, Ethan?
I do.
No.
I hope so.
No.
I'm surprised we didn't make it the model of the atom.
You can.
No, I'm surprised we didn't as a class.
Yeah,
'Cause
we
I thought
just didn't
that
have
was
time.
something typical as like a chemistry class.
But I mean, you could if you wanted to. Alright, so we're talking about this with delocalization. We had this yesterday in class. I just didn't have the picture up for it. But just showing you, okay, how for this one, because the electrons vibrate in between them, the just drawing it just one way or the other isn't technically correct. So because that, we'll draw both of them showing how it vibrates or resonances back and forth between them. We also do this in ozone and benzene, so not just metallic bonds, but it's a property of metallic bonds. Alright. So, we talked about the different types of shapes yesterday as well. For this one, because it's 4 atoms bonded to this one central atom, what shape is this? That has to do with the idea of 4 atoms bonded. It's not that. I don't have a slide for that one. But, what is this shape called? Quentin? Tetrahedral. Because tetra means 4, so there's 4 atoms bonded to that central one. Alright, yes?
What tetrahedron is that?
That is technically tetrahedron is a square shape. So make a note for that one. Then in geometry, that's whenever that one, that's like basically a square. So tetrahedral has to do with the idea. What? Yeah. So tetrahedral. So just be careful as you're going through it. So your book compares it to tetrahedron, and I know it compares it to it, so just be careful. This is technically tetrahedral.
I said that because the same hedron, that's what I remember.
Tetrahedral. Just remember tetrahedral. Alright. So, if you have 3 atoms bonded to a central atom, but you have a region of unpaired electrons like this one, that's what this is showing you. And again, we try to draw it as like the balloon shape just to help represent that it's taking up more space. That's why your textbook tries to draw it like that, and that's why my drawing like that, showing you, okay, it takes up more space. Why do these electrons take up more space since they're not bonded to anything? Why do they take up more space? So, raise your hand, do you think you know? Talked about the thing very briefly yesterday. Alright, the electron. What is the charge of electrons? Ethan.
Negative.
Negative. So do they like to be next to each other? No, so they will shimmy away from each other. These in the bond, they don't like each other either, but they're attracted to the positive, like in the hydrogen, or they're attracted to the positive, like in the carbon. And so because of that, they will stay put even though they don't really like each other. Now let's look on these will spread out more. So this is what shape then? Chris, sorry, what's your name? Because it looks like a tripod, but you can't make tripod on quizzing test.
Trigon.
The second half of the word.
Pyramidal.
Pyramidal. So good job for it. Yeah. Your book gives a slightly different pronunciation for it. So pyramidal is how you're technically supposed to say it, but yeah, pyramidal is how people say it typically fast for it. Alright, speaking of this, I think it's as far as we got yesterday. I think we made it to angular very briefly for it. So for something like this, for water, that's why it has this shape for it. Is because it has two regions of unpaired electrons. I think I talked about it, and then I think I ran out of time yesterday. So, like for oxygen, it starts off with how many electrons? Ethan? You're right, it's not enough, but how many?
6.
Good job. So 1, 2, 3, 4, 5, 6, and then these hydrogen will share one. So each hydrogen's happy that has those two regions of unpaired electrons. So it'll push the bonds a little bit closer together because they don't like it. That's how come typically if you're drawing it fast, we'll draw it like this. But technically, whenever you're drawing the Lewis structures of it, you need to include those extra dots so that way I know, okay, you know the region of unpaired electrons. You don't have to draw the like balloons around them. I do that just to help represent it. But if you just draw just the dots without the balloons, you're fine as you're going through it. Alright, so this is what shape, Ethan?
Trigonal pyramidal.
There's 3 atoms bonded? Okay, so we name them based on how many atoms are bonded to this one. So there's one atom in the center and then 2 are bonded, but this one's name is a little bit weird. Yeah, angular. But that's how come it's not trigonal, because even though there is 3 atoms, we name it we name it based on how many are bonded to that central atom. Okay, what's your
Isn't
question?
angular just like a really ugly fish that has a full bond inside?
Yep. If that helps you to remember, I don't care. But whatever helps you to remember it. Alright, so angular geometry. Alright, linear molecules. Alright, if you're talking about linear in geometry, what does that mean?
Straight.
Straight line. So that's what this one is. It's pretty much a straight line. There are 2 different types for this one. If I have 2 molecules, can I have any other type of geometry or shape if there's just 2 points for it? Chris? She can't hear that. She might have heard that. He said no. So because of that, 2 molecules will always have a linear geometry because the shortest distance between any 2 points is a straight line. Sometimes though, if you have 3 molecules total, it could be angular like this, depending on how it's bonded, how many electrons it starts off with, or it could be linear like this. That's why it's important to note, does it have any other extra valence electrons? The example your book gives is with beryllium. Now, you'll notice, beryllium in this situation is not following the octet rule, and that's okay. I will tell you on quizzes or tests or in your homework if it doesn't follow the octet rule, because there are a couple of exceptions for it. So, for this one, in this case, beryllium is not following the octet rule for it, but there's no another paired electrons for it. So, beryllium has its electrons locked here and here. Now, keep in mind, is fluorine happy in this situation? Quentin? Yes, fluorine is happy. So basically fluorine is forcing beryllium to be unhappy in this situation because beryllium would rather lose its electrons altogether, but fluorine says no, you're gonna share with me. So that's why this shape is linear because there's no other unpaired, so fluorine will try to spread out from each other as much as possible. Keep in mind, what will fluorine's charge be? Well, partial charge since they're sharing electrons. Keep in mind, which one wants it more, beryllium or fluorine? Fluorine. So they're going to be partial what then?
Negative.
Partial negative, and you're right that this bond here is a polar bond because both of them, because fluorine is pulling it slightly towards it. We're going to talk about though, would this molecule be considered polar in a second? Though, probably more of it tomorrow, honestly. Does anyone think they know? Would we consider this molecule polar, even though there is polar bonds in it?
Yes.
Why?
Because God said so.
No, not quite. idea of unequal sharing on either side. We'll talk about that as this one a little bit later though, because I gotta finish up talking about shapes. Alright, so the next one your book talks about is the last type of trigonal with the three of them. Now, your book points out for this one, this is fluorine again, because fluorine's forcing other atoms to not be happy. It's doing it. Well, remember, fluorine is the most electronegative, so it will force other atoms, and in some cases, to just be unhappy in this case. So, each fluorine's happy in this situation, but boron is not happy, and your book points out, okay, boron is not obeying it in this situation, but fluorine is making it occur. But keep in mind, is there any unpaired electrons around boron? Based on how I've drawn it? No. So, because of that, there's no region of unpaired electrons like for this one. So because of it, it will lay as flat as possible because they want to spread out from each other. If they do it like this, they're slightly closer together, so they will stay entirely flat. So that's the difference between these two, is these two are slightly raised or has a slight kind of tripod shape. Well, this one is basically flat. They want to spread out from each other as far as possible because each of these fluorines will be slightly negative or partial negative. This one is called trigonal planar with the idea of a single plane in geometry. That's the same idea where it's coming from. Wow. So this one is what shape then, Chris? Yep. You seem excited. You would yay.
Tetra.
Oh, nope, there's only 3 bonded to essential atoms, so that's how many I'm talking about.
Trigonal.
Good job. And this one is trigonal, because it's in one plane. Planar. So those are the 2 differences. So they both have 3 atoms, but this one is slightly raised while this one's not. So sometimes that throws off students. So make a note of that. Anyone have any questions about that idea though, or the shapes? Because those are the shapes that you need to know. There's only basically 5 of them, so they're not that hard, but figuring them out can be a little bit tricky. Anyone have any questions about them? Alright, let's go back over. Yeah, we're gonna go ahead and do that. So let's go back over like the homework section for number 2 now, but let's do the other ones, the ones that you didn't do yet. So B, D, F, and H. So let's go over those really quick. Alright, I'm telling you right now, this first one does not obey the octet rule because fluorine's forcing it to do this. So it's aluminum.
Unconsensual.
Yeah. And then fluorine is doing this to it. Alright, so based on that, so there's no unpaired electrons around it. So what shape would that be? Ethan?
Trigonal through middle.
Alright, so it's trigonal, but which one? Because there's no other paired of electrons. So which one is the way for them to get as far with? What? Planar. So that's what this one is. With the idea of, okay, they want to get as far apart from each other as possible so they can get entirely flat because there's no other unpaired electrons around them to force them to be pushed down together. Alright, I'm gonna get over to the page because I lost my spot. Alright, so D for this one. So it's HBr. Alright, so for this one, how would this one bond up, Quentin? What? Okay, what? Okay, yes. Now, keep in mind, bromine starts off with how many?
That's a long H. 7.
7. So how many more does it need to be happy?
1.
Yep, so is bromine happy in the situation? Is hydrogen happy? Yay, everybody's happy. And you're right that yes, this is of course linear. Alright, F. Alright.
F in the chat.
You want this one?
No.
Okay, this one is a little bit harder though. So, yeah, we can talk through it for this one. For this one, it's ozone. Now, do you remember what's special about ozone?
It comes from sockets.
We talked about that, okay, yes. But, do you remember what's special based on this slide? What's special about ozone?
No. I don't see anything weird about that.
What?
Sunless?
So, what's special about electrons?
Delocalized.
They're delocalized. So, they're going to vibrate back and forth for this one. You can either have it bonded like this. I'm just telling you this one because this one takes way too long to explain. So, you can either have it bond. Nope, I didn't. So basically, this pair will vibrate back and forth between them for it. So this is the shape for it though. So what shape is this? Whenever.
Trigonal. Pyramidal.
Alright, so,
Trigonal plater.
so for this,
Angular.
what?
Angular.
It is angular. Because, yeah, this one's a harder one, but it's because they want to spread out from each other as much as possible, so it makes a really weird shape whenever you're supposed to do it. So you got a hard one. Do you want H, since that one's much easier?
Like a 1H.
You look both sides, but I feel like you need H as a pick me up. Alright, do H, because H is a lot easier than that one.
Angular.
Is that your turn?
Put a C
Where?
in the middle.
Good job. And then there's the 4 CLs around it. Alright, so is CL happy as I've drawn it, or do I need to do anything else?
It is good.
It is good. So now is carbon happy? So what shape is this?
I don't want to say.
You have to say it.
I don't like the word.
You have to say it.
Tetrahedral.
Good job, tetrahedral. Alright, anyone have any questions about that?
Like cousin.
Alright, we'll go ahead and we'll stop there. We'll finish talking about polar molecules versus non-polar molecules tomorrow, and then we'll do the lab probably on Friday. So because of that, make sure everybody's studying those, so you can tell which shape is which, because you're not going to have time on Friday to ask me, what is this, over and over again. Don't have time, so you got to move as quickly as possible. If you want to build as many molecules as you can, you got to make sure that you're moving as quickly as possible.